Hello everyone and welcome to my next tutorial. In this video series, I'll be explaining some state management concepts in React. This will include Redux, Redux Toolkit, and Redux Saga. In the first part of the video series, I'll be going through some theory, and later on we'll walk through some actual code examples together. Before we get started, I just want to mention that I have a GitHub repo with a bunch of notes and references that inspired this video series. So if that interests you, you can check the link in the description. Let's start with an introduction to Redux by going through concepts and data flow at a high level. But first, what is Redux? Well, Redux can be summarized with the following. It allows you to manage your app state in a single place, and that's really what Redux boils down to. When would we want to use Redux? There's a lot of valid use cases for it, and I'll list some of these here. Maybe you have large amounts of application state that is needed across many places in the app. What if the app state is updated frequently? Maybe the logic to update that state is complex. Or what if the app has a big code base and many people are working on it at the same time? Maybe you want to see how that state is being updated over time. These are all valid use cases where Redux can come in really handy. But, like any tool, it has trade-offs, and I think it's at least important to be aware of these drawbacks. With Redux, there's more concepts to learn and more code to write. Redux can also add some complexity to your code base. So you can think about these benefits and drawbacks before incorporating Redux into your application. Now let's talk about some Redux concepts that we'll see again and again. First is the store. Redux application state lives in an object called the store. Next is an action. An action is an event that occurs in the app to trigger updates in the state. Typically, it occurs based on user input. You can think of an action as an event that describes something that happened in the application. In more detail, an action is a plain JavaScript object that typically has two fields, a type and a payload. The type is a string that gives the action a descriptive name, and a payload is additional information about what happened. So here's an example code snippet. We have an add to do action, the type is todos/todo added, and payload is buy milk. So this would be a good example for a to-do list application. Next is the concept of a reducer. A reducer is simply a function that receives the current state and an action object and then decides how to update the state. You can think of a reducer as an event listener, which handles events based on the received action. So just to reiterate, a reducer takes the current state and action and then computes the new state. Now let's visualize all the concepts that we just learned with an illustration. I'll put the link for this image in the description of the video. So let's pretend that a user clicks deposit $10. What would happen? Let's summarize that data flow. First, the action is dispatched to the Redux store. Then, the store runs the reducer function and calculates the new state value. After that, the store notifies all parts of the UI that are subscribed, and any component that sees its data has changed forces a re-render with the new data, so it can update what's shown on the screen. Now that we've summarized Redux, let's get into some code snippets of Redux Toolkit so we can see some more tangible examples. What is Redux Toolkit exactly? Well, Redux Toolkit is a package intended to be the standard way to write Redux logic. Basically, it makes writing Redux logic much easier. Let's have a look at an example code snippet for a counter application. The main idea is to first create a slice of state using the createSlice function from Redux Toolkit. Then we pass a couple parameters. First is the name. In this example, we have a name of counter. Then we pass in an initial state. In this example, we have initial state value of 0. Last but not least, we supply one or more reducers to define how state can be updated. So here we have first an increment reducer, then we have a decrement reducer, and finally increment by amount reducer. Finally, at the bottom of the file, we'll see that we export the actions and reducer for the whole slice. At a high level, we can see that Redux Toolkit makes it easy to write Redux logic in a consistent manner. Now in React components, how do we use that Redux state? Well, there's two hooks that we'll become familiar with. First is the useSelector hook. This hook subscribes to the Redux store and forces the component to re-render when the selector that we pass in changes. So in this case, whenever the counter value changes, the component will re-render. Next, we have the useDispatch hook. You can use it to dispatch actions as needed. Finally, let's talk about Redux Saga. What is Redux Saga? Well, Redux Saga is what's called a Redux middleware. Basically, it's a tool to help us manage async tasks such as data fetching. Now let's look at the Redux data flow. It's very similar to what we saw before with two additional pieces, an API and a middleware. How is it different? Well, we still dispatch an action, but now when the action reaches the middleware can make an async call to the API, and with the response it gets, the middleware can then update the Redux store. Now let's get into a Redux Saga code snippet. Before we get into the details, I just want to remind you that I'll be going through a tutorial step by step later on, so don't worry if you don't understand everything at first. There's two main components we'll see here: worker sagas and watcher sagas. A worker saga is what actually does the work. It'll handle the action. A watcher saga, on the other hand, is what watches out for a dispatched action and then forks a worker. We'll also see that there's two watchers here, and that's because we can have different types of concurrency. So if we want to allow concurrent fetches, we can use takeEvery, or if we don't want to use concurrent fetches, we can call takeLatest. We'll also notice that the syntax might seem a bit different, and that's because sagas are implemented as generator functions. We don't need to go into too much detail about generator functions, because most of it is handled implicitly by Redux Saga, but it's good to know that a generator function is just a function that can be exited and later re-entered. So if we take a closer look at this example, we'll also see that there's things like yield call and yield put. Yield call instructs the middleware to call a function with a specified arguments. Yield put, on the other hand, instructs the middleware to schedule the dispatching of an action to the store. And if we trace the code of the worker saga, we'll see that the first line is const user equal to yield call api.fetchUser, and we also pass in action.payload.userID. So what this is saying is, let's make an API fetch and fetch the user and collect the response. Then we'll see yield put, user fetch succeeded or user fetch failed. And what we're saying in that case is, depending on the response from the API, we'll either dispatch a succeeded action or a failed action. Again, I think it's important to talk about drawbacks. While Redux Saga is a really powerful tool and can do a lot of things like concurrency, there are trade-offs. Redux Saga might seem like overkill for a simple CRUD application. It might be adding a lot of overhead for a simple app. There are alternatives to this. One is React Query, which is very popular, and I might discuss it in a different video. Now that we went through a whole bunch of theory, let's get our hands dirty by actually building an application that uses Redux, Redux Toolkit, and Redux Saga. If that interests you, stay tuned for the next video.